Good morning. Myself, Dr. S. Muthusundari. Today, we are going to discuss about the I/O interfacing. Already in the last class, we have discussed about the 8255 interfacing. And now we are going to discuss about the timer counter interface, which is called in the name of 8253 or 8254 timer. Timer counter, which is also developed by the Intel family. The name of this interface, which is called as 8253 or 8254. It is also a chip. The main purpose of the timer counter is it generates the accurate time delays and used for applications such as real-time clock. Next, we can discuss about the features of 8254. There are 7 features are included in the 8254. The first feature is it is the generation of the accurate time delay, and there are 6 different programming operating modes are here, and timer and control operation is going to be performed. Here it may be used the counting in binary or BCD form. It is going to interrupt the processor, and then 3 independent 16-bit counters are here. The counters, which is called as channels, and then it is compatible with all the microprocessors. Microprocessor in the sense we are having different types of families: 8086 family, 8085 family, 8088 family, 8087 family, like that. So it is compatible with all the microprocessors. So these are the features of 8254. Next, we will discuss about the pin diagram of 8253 or 8254. So here there are 24 pin diagrams are available. So here 24 in the sense totally it is divided into 12 and 12 each. So 12 will be in the left hand side and 12 will be in the right hand side. So here in that 12, already people are knowing that definitely 1 pin for the power supply and 1 pin for the ground. So 2 pins are allotted for that, and then remaining you will be having here. There are data buses will be available and the address buses also will be available. So totally 8 data buses. So D0 to D7, which is available in the left hand side of the pin diagram. And then in the right hand side, we are having up 2 pins for the address bus A1 and the A0. And then remaining 2 pins, which is for the either the read operation is going to be performed or the write operation is going to be performed, or we have to make use of the chip select. Okay, and then as said, the features of the 8254, here it uses 3 independent counters. So the counters, which is otherwise it is called as the channels. So here we are having 3 bits of each counters are here. So one is called as counter 0, another one is called as counter 1, and another one is called as counter 2. So counter 0, which is having 3 bits. One is for the clock, another one is for the output, and another one is for the gate. So clock 0, output 0, and then gate 0. These 3 bits are called as the counter 0. So similarly, counter 1 and the counter 2. So 3 into 3, so totally 9 pins are allotted for that. So it is the overall pin configuration of 24 for the 8253 or 8254. So based on the address status, either A1 or 0, the corresponding function will be activated. If both are 0, if 2 bits in the sense the possibles are 2 power 2, 4 combinations. So all are 0, 0 and 1 combination, 1 and 0 combination, and 1, 1, 1 combinations. So if both are 0 in the sense, counter 0 will be activated. If it is of 0 and 1 in the sense, counter 1 will be activated. If it is of 1 and 0 in the sense, it is equivalent to the number 2. So the counter 2 will be activated. If both are 1 in the sense, controlled word will be activated. So next we move on to the signals of the 8253 or 8254. So WR for the write operation, CS for the chip select signal, A0 and A1 for the address lines. Next clock is there, output is there, gate is there. So clock in the sense, this is the clock input for the counter. The counter is 16 bits. output. The single output line is the signal, that is the final program output of the device. Gate. So this is the input, can act as a gate for the clock input line, or it can act as a start pulse. Gate in the sense, already people have studied in your digital, either AND gate will be there, OR gate will be there, certain operations also will be there. How many input lines we are giving according to the based on the truth table value, it will be calculated. Next, we move on to the block diagram of the 8253. So here, totally, we are having 4 components of the block diagram. One is already people are familiar with the data bus buffer will be there, and another one is read and write control logic will be there, then control word register, and another one is we are using the counters. Okay, so data bus buffer, totally 8 bits are allotted for that. Read or write control logic, here either read operation is being performed, or write operation, or chip select, or address lines, 2 bits of address lines. And then control word. Okay, and then based on the chip select only, either counter 0, counter 1, counter 2, or control word will be activated. And then in the right hand side, it shows all about the channels. So here 3 independent counters are used. So counter 0, counter 1, and then counter 2. Each and every counter, we are having of 3 lines. So 2 input lines and 1 output lines. Gate and the clock are treated as the input lines and 1 output lines. So counter 0 in the sense clock 0, gate 0, output 0. Counter 1 in the sense clock 1, gate 1, output 1. Counter 2 in the sense clock 2, gate 2, output 2. So this is called as the block diagram of the 8253. So now we are going to express the control word register. So based on the input read operation and the write operation and the address lines only, the corresponding functions will be activated. This is called as a truth table. So now we are having either counter 0 will be activated, or counter 1 will be activated, and counter 2 will be activated, or control word or control register will be activated. So on what basis the particular function will be activated? So if 2 lines, address lines, so either the address lines may be 0, 0 in the sense counter 0 will be activated, address lines 0, 1 in the sense counter 1 will be activated, 1, 0 in the sense that is counter 2 will be activated. If both are 1 in the sense, control word will be activated. So at the same time, read and write operation also being concentrated. If either read is chosen and the remaining is 0, 0, load counter 0. If write operation is activated, then read the counter 0. So based on that 1 and 0 or 0, 1, according to that, either load operation of the counter 1 or read operation of the counter 1. Similarly, for the load operation of the counter 2, read operation of the counter 2, similarly, write mode also will be activated. So this is the truth table. So this is the 8254 programmatical part. So how the control word, this is the format of the control word. Whenever we are speaking about the control word, it is all about the 8-bit format. So 0 to 7. So the first bit for the binary coded decimal, and then the remaining 3 bits are called as the mode selection, M0, M1, M2. So based on this only, we are having some 5 different modes, either mode 0 or mode 1. According to these values only, it is going to for selecting the mode. And the bit number 4 and 5 for the read or write operation, and the last 2, 6 and 7, it is for the selection of the counter value. Either counter 0 will be activated, counter 1 or counter 2, or last read back command will be activated, or control word will be activated. So here read or write operation also based on that 0, 0 or 0, 1 or 1, 0 or 1, 1. According to that, counter latch command will be performed, or read write least significant byte will be, or read write most significant byte, like that certain things will be activated. So already I said there are 5 different modes of operation. So mode 0, mode 1, mode 2, mode 3, and then mode 4. If it is mode 0 in the sense interrupt or terminal count will be activated. If mode 1, then the sense it is of hardware read trigger 1 shot. If it is of mode 2, rate generator will be activated. If it is of mode 3, square wave generated. If it is of mode 4, software or hardware trigger strobe. So these are all called as the 8254 interrupts. Thank you.